As a kid, I always wanted to have robot arms. The allure of designing a superhuman limb is really what grabbed me into the engineering field. But the more I delved into the subject, the more I realized that steel and aluminum alloys can't carry a candle to crystallized calcium. I mean, name one thing that regenerates and gets stronger the more you use it. My car certainly doesn't. Now, the more we delve into this, the more we realize that bone marrow itself is an incredibly important substance. You see, give me a second. Bone marrow is an incredibly important substance, and the more we delve into it, the more motion that we put into it, the better we become. Bone marrow is a highly viscous fluid that's actually under pressure inside your bone. It's an amalgam of fat cells, vasculature, and white blood cells that has a consistency between applesauce and ketchup. Now, as you move, bone marrow moves inside your bone and stimulates your mesenchymal stem cells, commonly called MSCs. These are the reason why exercise is so critical to preventing osteoporosis. You see, not only are they important for preventing osteoporosis, they're also really important for the regulation of your immune, nervous, and muscular systems. This is the reason why bone marrow research is so critical. And the more we delve into it, the more we find that we need to understand what the motion inside your bone actually looks like. This is where I come in. In order to study this, I 3D printed plastic models to represent bone, and then filled them with a gel to represent marrow. By vibrating them under a high-speed camera, we were able to generate three-dimensional models of what is actually happening inside your bones as you move. So now you might be asking, why do you care about plastic models and a bunch of jello? And what's with all these rhetorical questions? Now I'm glad you asked. You see, a bulk of research in the past 2 decades has shown us that the motion inside your bones actually determines how your cells behave. So thus, if we know what motion causes what behavior, we can actually tell these cells what to do. Let's put it another way. Imagine these cells are citizens to be in a city. My team and I are the builders. We build the frames, we build the floors, and we assign where the rooms are in the city. Then we ship it off to our partners in Texas. They furnish the rooms, stock the fridge the cells don't starve, and finally let the cells into their city. Now, depending on where the cells go, they're going to become the police-like white blood cells or even the osteocytes, repairing the city as it breaks. And all of it has to do with where we put the rooms and how big we made the public spaces. Understanding and controlling these cells is critical to not only prevent osteoporosis, but also to improve everybody's quality of life. And I really hope that my research can help narrow down on the issues that we're all facing. Thank you.